start with 5 raised to the power of minus 2. Before I proceed, some of you will think 5 raised to the power minus 2 simply means 5 raised to the power 2 means like 5 times 5 or minus 5 times minus 5. No, 5 raised to the power of minus 2 is not equal to minus 25. So how to solve this? You simply find the reciprocal of a number, that is putting 1 all over the number and the power. So this becomes 1 over 5 raised to the power of 2. This is the final answer. Or you can go further and say equal to 1 all over what? 25. Remember, this rule simply means to remove this negative power or the negative sign in the power to get the corresponding reciprocal. So let's have a second example. If we have 4 raised to the power of minus 3, it's the same process. 1 all over 4 raised to the power of 3. So this, just know that once you have a negative index, remove the negative sign and leave it as 1 all over your base and then your power. This is just to remove the negative sign in your number. So forging ahead, we go to number 5, which is the 0 index. Here, any non-zero number or base raised to the power of 0 is equal to 1. Yes, no matter how big or small the number is, so far it is not 0. When it is raised to the power of 0, then the number is equal to 1. Let's look at examples. Here, example I, we have 3 raised to the power 0. So far this number has 0 as its power or exponent. It is going to be equal to what? 1. Let's assume we have an example like this. 2 raised to the power 0 times 3 raised to the power 0. How would you solve this? It is still the same process. 2 raised to the power 0 is 1, multiplied by 3 raised to the power 0 is also 1. Therefore, our answer is equal to what? 1. What about when we have an example like this? X plus y raised to the power of 0. What is going to be the answer? It is still the same thing. This is termed as a variable. So therefore, the answer is going to be equal to what? 1. Okay, moving on to number 6. We have the power of quotients. Now, what does this mean? Here, when a fraction, which can also be termed as a quotient, is raised to a power, this becomes, or this is equivalent to raising both the numerator and the denominator to the same power. Now, what does this imply? When a fraction has a power, how can you solve it? By raising both the numerator and denominator to that same power. Let's look at examples. Example I, if we have x all over y raised to the power of 3. This simply means x raised to the power of 3 all over y raised to the power of 3. And if we have example II, 2 all over 3 raised to the power of 2. What does this mean? This simply means 2 raised to the power of 2 all over 3 raised to the power of 3. This becomes 4 all over 27. Simple. Well, if you have any questions so far, do not forget to put your questions in the comment section and I will respond to them immediately. We have the power of products. Number 7, power of products. Here, when the product of numbers or bases is raised to a power, that power is applied to each base of that product. Yes, so in the power of the product, when the product of numbers or the bases is raised to a power, that power is applied to each base of that product. It has an expression. So let's assume we have x multiplied by y raised to the power of n. This becomes x raised to the power of n times y raised to the power of n. Let's quickly do one example. So let's assume we have 2 multiplied by 3 raised to the power of 3. This becomes 2 raised to the power of 3 times 3 raised to the power of 3. Yes, you can leave your answer like this in index form, or if you're asked to go on and simplify, you can as well simplify it. In the final one, we have the root law or the root rule. Here, when a base has a fraction as its power, the denominator of that fraction becomes the roots of the base, while the numerator of that fraction becomes the power of the base in the roots. Yes, here when a base has a fraction as its power, the denominator of that fraction becomes the root of that base, while the numerator of that fraction becomes the power of that base in the root. Let's look at this example. Example I, let's assume x raised to the power of 1 all over n. How can we simplify this? The denominator of this fraction becomes the root. Therefore, root n of base x and raised to power 1 is still the same x. So I can either write 1 here, or I can write it as root n of x. Let's have another example. 9 raised to the power of 1 over 2. How can we simplify this? The same process. This denominator becomes the square root. If it is over 3, it becomes the cube root. So since it is 2, it becomes the square root. Therefore, square root of 9 raised to the power of 1, which is still 9. This becomes our final answer. I've picked out some examples for us to simplify already. So here we have it. Examples, simplify the following. Let's observe them. Number 1, 10 raised to the power of minus 3. Number 2, 8 raised to the power of 2 over 3. And number 3, 3 raised to the power 9 divided by 3 raised to the power of 3. So for us to begin, we need to observe what laws we are going to need to be able to simplify these correctly. So looking at number 1, we can see that this is a negative index. The power here has a negative sign. Number 2 is going to be a root law because the base has a fraction as its power. And number 3, when the bases to be divided are the same, we subtract the powers. So number 3 is quotient rule or division rule. So let's begin. Solutions. Number 1, 10 raised to the power minus 3. The first step is to remove this negative sign as its reciprocal. This becomes 1 all over the base become here, and the power remains the same, which is equal to 1 all over 10 times 10 times 10. That is 1 all over 1,000. So you can leave your answer in index form like this, with the base having its power, or in a simplified form like this. Number 2, 8 raised to the power of 2 all over 3. Using the last law, the denominator of this fraction becomes the root of this base. Therefore, this becomes the cube root of 8 raised to the power of 2. So, you can leave an answer in index form like this. And then number 3, we have the same basis but different powers. So once the bases are the same, you pick 1 and you subtract the powers. This becomes 3 raised to the power of 6. Thank you. So please, if you have questions, you can drop them in the comment section. I will respond to them. In our next video, we're going to look at WAEC questions involving simple exponential or indical equations and how we can solve them. So stay tuned and see you in the next class. Bye.